Stop what you're doing right now. Stare at the screen in your hand, feel the chair beneath you, or the light moving outside the window. Then, answer honestly. How certain are you that they exist, truly exist? This is no philosophical puzzle. It's a searing challenge posed by quantum mechanics, the backbone of modern physics. Scientists have discovered that reality may not exist all the time, but snaps into shape the moment we observe it. Welcome to Science Beyond. Today we'll step through the cracks of common sense and into a truth stranger than science fiction. The world you live in might not have existed at all. Chapter 1. The Crack in Reality. Planck pushes open the half-closed door. It all began with a seemingly trivial question. Why does a piece of iron change color when heated? From dull red to orange and yellow, until it blazes bright white. To us, it's the most ordinary thing in the world. But in 1900, at the Berlin Institute for Theoretical Physics, Professor Max Planck couldn't sleep over it. He tried every known classical physics formula, Newtonian mechanics, thermodynamics, all of them failed. That gentle spectral curve lay across the perfect edifice of classical physics like a mocking crack. Desperate, this rigorously precise, almost rigid scientist made what he called a desperate act of an assumption. Energy is not released continuously like a flowing river, but in tiny, discrete packets, emitted, quantized, like bullets. He named them quanta. It's as if a painter discovered that all the colors making up the world are actually pieced together from countless tiny, indivisible dots of color, pixels. Planck himself couldn't believe it. He said, "This is just a stopgap to get the right results. I do not believe it has real physical meaning." Yet this stopgap not only solved the black-body radiation problem perfectly, earning him the 1918 Nobel Prize in Physics, but also acted as a key that unexpectedly pried open a door to a whole new world, the quantum world. What lay beyond that door would shatter two cornerstones of human cognition: continuity and certainty. Chapter 2. The Double-Slit Experiment. Reality's cheating scene. If the world is quantized, how does it actually work? Scientists designed a device that sounded like a thought experiment, yet it yielded results far stranger than any fantasy. This is the famous electron double-slit interference experiment. Picture a wall with two narrow slits cut into it. You take an electron gun and fire tiny electrons at it. Common sense says, like a machine gun spraying bullets, the electrons should pass through either the left slit or the right, leaving two bright streaks on the screen behind. But the quantum world let out its first cold laugh. What appeared on the screen was an intricate pattern of light and dark fringes, just like water waves interfering with each other. Scientists were baffled. Could the electrons be conspiring with one another to form a wave? So they slowed the firing to a crawl, one electron at a time. Fire one, wait, fire another. And yet, the wave pattern still slowly emerged. This meant that each solitary electron passed through both slits at the same time and interfered with itself. The electron is both a particle and a wave. It was enough to send classical physics into cardiac arrest. But the real magic was only just beginning. To see which slit the electron actually took, scientists set up the most precise detectors next to the slits, acting as the eye of God. When observation began, the nightmare unfolded. The interference pattern vanished in an instant, leaving only two neat bullet hole streaks on the screen. The moment observation stopped, that ghostly wave pattern quietly reappeared. Reality wears two completely different faces, when it's being watched and when it's not. This was no longer an experiment. It was a trial of our belief in objective reality. It was as if the universe was saying, there is no absolute being there. Existence is an act inseparable from observation. The fundamental particles that make up you, me, and everything in the universe are so deeply affected by consciousness or measurement. So where then is the foundation of the reality of the macroscopic world they build? Chapter 3. Schrödinger's cat. a prisoner in a box, and humanity's cognitive predicament. Faced with such a bizarre microscopic world, physicists put forward the Copenhagen interpretation. When a particle is not observed, it exists in a superposition of all possible states. The moment it is observed, it randomly collapses into a single definite state. It sounded absurd enough as it was. Yet Erwin Schrödinger, one of the founders of quantum mechanics, was deeply uneasy. In 1935, to expose the absurdity of this interpretation when scaled up to the macroscopic world, he conceived a famous thought experiment: Schrödinger's cat. Inside a sealed steel box, there is a cat, a radioactive atom, a Geiger counter, and a vial of poison. The atom has a 50% chance of decaying within an hour. If it decays, the counter triggers, shatters the poison vial, and the cat dies. If it doesn't decay, the cat lives. According to the Copenhagen interpretation, before the box is opened and observed, the atom exists in a superposition of decayed and undecayed, and so the cat is trapped in a terrifying superposition of both alive and dead. Schrödinger's intention was pure satire. Look, this is the absurd result your logic leads to. But this imaginary cat became physics' most famous prisoner, pushing the entire scientific community into a dilemma. You cannot accept a macroscopic cat being both alive and dead, yet you cannot deny that a microscopic superposition, amplified by an elaborate device, must lead to a macroscopic one. This box imprisons far more than just a cat. It imprisons humanity's powerlessness to understand the quantum world with classical logic. We are stuck in the crack between the microscopic and the macroscopic, desperate for a new way forward, one that explains the experiments without destroying our rational understanding. Chapter 4: The Many-World Symphony, a Lonely Prophet in an Infinite Universe. In 1957, a PhD student at Princeton University named Hugh Everett submitted an unassuming doctoral thesis. He proposed a solution that was simplicity itself and madness itself. Accept all possibilities and let them all become real. In his vision, there is no such thing as collapse. Every quantum process, like whether that radioactive atom decays or not, causes the universe itself to split. In one world, the atom decays and the cat dies. In another entirely real, physically isolated world, the atom does not decay and the cat lives. The observer, you, also splits at the same time, stepping into both worlds with completely coherent memories and experiences. This means that the moment you decide to drink coffee or tea right now, the universe splits. Another you in another world is sipping the drink you chose to pass on. History is not a single one-way road. It is a vast, ever-branching forest stretching into infinity. Yet this insight, far ahead of its time, was met with unanimous silence and mockery from the scientific community. His advisor, John Wheeler, would later come around to support it, but the mainstream academia of the time dismissed it as metaphysics and science fiction. Heartbroken, Everett, once a rising star of academia, turned his back on it all, joining the Department of Defense. He channeled his genius into calculating missile trajectories and buried his cosmic model deep away. In 1982, at just 51 years old, he died of a sudden heart attack. Following his eccentric last wish, his ashes were scattered in a garbage dump. After all, I'm still alive in other worlds. His family was scarred by his estrangement and his failure. His son Mark long thought of his father as a cold, odd man. Years after his father's death, Mark opened a dust-covered box. Inside were the rejected manuscript, notes, and calculations, the world he'd turned his back on. In that moment, understanding struck like lightning. He later recalled, "He wasn't crazy, he was a genius prophet, exiled in his own time." And more heartbreaking still, Mark said, he lived his whole life in those countless parallel worlds, but we, his family, in reality, were never allowed in. History has finally given him the justice he deserved. Today, the many worlds interpretation stands shoulder to shoulder with the Copenhagen interpretation. one of the most mainstream and self-consistent interpretations of quantum mechanics. It not only guides the cutting edge of theoretical physics, but also deeply influences the philosophical foundations of quantum computing, cosmology, and even artificial intelligence. When NASA ponders interstellar communication and Google trains its massive AI models, neither can escape this framework of infinite possibility. Hugh Everett, a prophet alone and unrecognized in life, immortal and celebrated in death, traded his own tragic loneliness for a cosmic vision for all humanity, one that is infinitely vast and infinitely awe-inspiring. Chapter 5. The Lesson of Entanglement. Spooky action at a distance. Across time and space. If the many worlds theory is a rhapsodic symphony, then quantum entanglement is its strangest and most undeniable note. This is no longer a thought experiment. It is a phenomenon repeatedly proven in laboratories around the world. When two particles interact, they form an entangled state. Even if they are later separated to opposite ends of the universe, measuring one particle instantly determines the state of the other. This instant action seems to defy the speed of light. Einstein famously dismissed it as spooky action at a distance. Yet nearly half a century of precise experiments, especially a series of tests after John Bell proposed his verification method, have ruthlessly confirmed the existence of this spookiness. At the microscopic level, our universe is inherently non-local, an interconnected whole. This entanglement is believed to be the physical foundation of future quantum communication and quantum internet. Entanglement offers a kind of support for the many worlds interpretation in its own way. If two entangled particles can coordinate instantly across space, then could the different historical branches split off from a single universe also be connected by some deeper, uncomprehended link? Reality has a structure far more exquisite and complex than our wildest fiction. Epilogue. We are seekers of meaning. Quantum mechanics does not claim that the world is virtual, but it has completely shattered the naive illusion of an objectively independent reality. We are both the audience and the performers, both the explorers and a single moment of creation itself. Next time you make a choice, perhaps you can think with a little awe and a little humor. In some distant parallel world is another you looking on, envying the life you have right now. The meaning of science may never lie in giving ultimate answers. It lies in forever expanding the frontiers of human imagination. Thank you for joining us on this walk along the edge of quantum reality. This is Science Beyond. We'll see you next time.